We're on page 10 of the 5.6 notes. When I made the test last night, I noticed that there wasn't a problem exactly like this one on the test. And so I'm like, I'm going to doctor up a problem and make it look more like the test. So this is me playing doctor right here. So cross this out because they didn't do it in the order that they showed on the other side. It's not wrong, but just cross this out and we're going to start from scratch. So add in, find A and B, because I noticed on the test they asked for two sides, not just one. And then go ahead and put this number in, 6 inches. So this is 4, this is 5 given, and then they're going to give this. The difference is they add for two different sides. I think maybe the B might be here and the 6 here, but it doesn't matter. It's all going to be set up the same way. So you're going to have to do two sets of proportions. So you cross out the B and its number, and you set up a proportion for A. And then you cross out the A and its number, and you set up a proportion for B. So this is a two-part problem on Alex. 2 answers, partial credit. So first we're going to find A. So cross out B and cross out the side that goes with B, okay? So we say, and let's go ahead and mark these with light colors, then we know what sides go together. And if you're ever questioning, side XY must go with side AB. So if the triangles are like tipped or one's turned or one's upside down, you can always figure out. And side BC goes with side YZ. So BC, YZ. And side AC goes with side XY. So AC goes with side XY. That way we have them color-coded and we know which ones to put together. I mean, it's kind of obvious because these are lined up together, but I've seen students do this to this and that to that, and that's not true. Left side to left side, right side to right side, base to base. And like I said, if one triangle's tipped and you can't tell, just use the letters to help you. So AB goes with XY, BC goes with YZ, AC goes with XC. So now we're ready to set up our proportions. So we're going to ignore the B for now because we're going to find A. So we say 4 goes with 8, which is the same proportion or same ratio as 5 goes with A. So as I'm explaining at the end of the video last time, and I kind of got cut off, if you start with the left triangle in the numerator, on the next fraction, you have to make sure the left triangle is in the numerator. So left to right, left to right. Order matters. You have to be consistent when you do proportions. So then we can set our cross products equal, and we get 4A equals 8 times 5 is 40. Divide by 4, divide by 4, and we get A equals 10. And remember, units count, so it's going to be 10, and we can see this is inches. So that'll be your first answer in Alex. Then your second answer will be from covering up A and doing a proportion with those. So 4 goes to 8 as 6 goes to B. So let's do that one in a different color. So left over right, so 4 over 8 equals 6 over B. So left to right, left over right. And then again, we solve in the same manner. So we get 4B equals 6 times 8, which is 48. Divide by 4, divide by 4, B is 12 inches. And I've done this one before in class together with the students, and they always tell me, oh, well, I just did 4 times 2, 6 times 2, 5 times 2. Yeah, I'm not going to give you that easy one on a test where you can look at it and tell what it's going to be. So you need to make sure you know how to set it up. If you were taking a paper pencil test, I would count this as half the points setting it up. Okay? So that is just like the test now that I changed it a bit. Okay, let's go to number 7. So, since you haven't gotten to do one by yourself, why don't you go ahead and try 7 right now? Okay, so to find B, we can label our pictures and make sure they're the same. So X, Y goes with AB. So X, Y in one color, AB in the same color. And then we have XZ. XZ goes with AC. So XZ in another color, AC in that same color. And remember on your test, they're going to have another number here and then like have A here, but you do it all the same. You just do 2 at a time. So we have as our proportion, and it doesn't matter which one you start with. You can do this over that equals this over that, or you could start with this one, just as long as you're consistent. So 30 corresponds with 36. And that is equal to, we have to start with the left-hand triangle because we started with the left here, 25 corresponds with B. So left over right, left over right. And then we simply cross multiply and we get 30B equals 36 times 25. I think that's 900. I'll verify in just a little bit. So 36 times 25, 900. And then we divide both sides by 30 to get B alone. So B equals 90 divided by 3 is 30. And then we look at the label and we say feet. So side B is 30 feet. So, want me to make this one look a little bit more like the test? Let me pause and come up with some numbers. Okay, so I want to pretend it's a test. So we found B, now we need to find A. Alex will probably make you find A first. So it has to give you another side and give you an A, obviously. So I tried to make it so it works out, kind of. So when I'm finding A, I can cover up 2 of them, just 2 of the same color, and then use the ones that are available. I could also put the B in for 30 and use it, but I don't recommend that because what if you made a mistake there? Then that's going to make you miss both of them. So that's why I usually cover up that. And so this left over right would be A over 33 equals left over right, 30 over 36. So this is just to make it look a little more like the test, so you have 2 to practice on. So setting our cross products equal, we have 36A equals 33 times 30. What is that, 990? So 36A equals 99 and add a 0. So then divide both sides by 36. So 9, I'm going to go ahead and check my work. So 33 times 30, 990, divided by 36, 27.5. So A is 27.5 feet. So that made it look a little bit more like the test because I know it had like 1 letter here and 1 letter over there. And I thought, is that going to confuse students? They just have to know, cross this one out when you do the first proportion and ignore these when you do the second proportion. Then it's just like a normal problem. Okay, we have one more left. Let's see how much you remember from your geometry days. Yeah, this one is packed full of geometry. That used to, well, I taught it for my first time right out of college, and I was scared to death. I mean, scared to death to teach geometry my first year out of college. But it ended up being my very favorite class. I love, love, love geometry. So, this one has a couple things in it that maybe you do or don't remember from geometry. One is, even if they don't tell us these triangles are similar, which I don't think they do, we know they are by a theorem in geometry that says if two angles of a triangle are equal, so we can assume this is a right angle and we can assume this is a right angle, and then see how they share this angle. So there's a thing called AA similarity. If two triangles have two angles that are the same, so we're looking at this little triangle and this big triangle, they both have a right angle, same. They share this angle, that's the little triangle's angle and it's the big triangle's angle. Then it was called AA similarity in high school geometry. That means those two trees are similar. So notice, I just skimmed through it real fast, but I don't see anywhere where they say they're similar. So you're probably going, well, how do I know they're similar? That's how you know. So they're assuming you remember that from geometry. How fat chance, right? Okay, so that's the first thing you have to know from geometry. The other thing that I taught my students that was so helpful was these are called overlapping triangles. Anytime you have overlapping triangles, you can make your life so much easier by taking them out of the picture. So overlapping means they share parts, one's inside the other one. So take them outside of the picture and do them that way, and then it just turns into a normal, easy problem. It's that easy. Split them out and then relabel them. So we can see that the long side of the right triangle is 33 meters. That was already given. It was just really light on my paper, so I wrote over the top of it. It says Renee, I am assuming this big-nosed person walking the dog. I don't know why they made their noses so long. That must be Renee, and so she's 2 meters tall. So this would be 2 meters. Renee, because she's the little triangle, or he, wishes to find the height of a tree. Oh, well, this is the height of the tree right here. So this is what I'm going to be calling X, because he or she wants to find how tall the tree is. So go to the triangle that has the tree in it and put X. Let's see what else. Okay, this is the only part that tricks students, so be careful. I say, okay, what should I label this? And so many students go, 23.5. I hope you're not saying that, because this is the side of the triangle. It has nothing whatsoever to do with 23.5. 23.5 is there, but I can use 23.5 to get this side. Wouldn't I take the whole side 33 minus how far Renee is from the tree, and won't that give me her side of the triangle here? And I believe that's 9.5 meters. Now I have a quote-unquote normal triangle problem. So does everybody understand why I subtracted that? This whole thing minus that gives me her piece of the triangle, which is her shadow. So let me just check my work. 33 minus 23.5. And yep, 9.5 it is. Show your screen, Norris. So now we're just ready to do left over right, left over right. So X over 2 equals 33 over 9.5. So 9.5x equals 66. And when you divide those, It says round to the nearest hundredth. So 6